Okay, so today we are going to be talking about the scientific method or scientific investigation. This is based on one of the assignments from one of the biology courses. However, it's good for all sciences. For sure. Hello, thanks for joining.
I thought
Hello.
somebody's ringing your doorbell at your house. I'm
I
sorry.
know, right? I'm glad the dogs aren't barking. Okay, so moving right along, today's agenda is going to look something like this. So again, we're going to talk about the scientific method for about 15 minutes and talk about questions and answers, whether they're on the scientific investigation or any other assignment.
Okay.
And then we'll kind of talk about some time management, maybe what works best for you, and then again, questions and answers.
Okay.
Just a couple ground rules. Please participate. This is the second live session I've done, and the first one I kind of felt like I was.
Hold on 1 second, okay?
Okay.
This is my neighbor I was telling you about, Mary.
Oh, hi, Mary.
Hi.
This is her. This is the lady who was a school teacher.
Oh, okay, great. Thank you for offering to help Sarah.
Oh, sure. Okay, back to my side session. Okay, go ahead.
Okay. So something else just to be courteous of others. If it gets super noisy, go ahead and mute your microphone so it cuts down the distractions for everyone. Manners, if we're discussing topics, please use kind words and appropriate words. And if you do have to leave this session early, they are recorded and then posted on your dashboard if you need to catch the rest of it or maybe review something. So, any questions so far?
No, I'm good. Hi, Rebecca.
Can you hear us, Rebecca?
Yes.
Okay, good. All right, so in order to really fully understand the scientific method or investigation, we need to talk about what these words mean. They're pretty simple, and we want to be able to, well, kind of say, well, to investigate, or investigation means that you're going to investigate something. Well, kind of going back to our elementary definitions. So investigation, if we look at investigations, we're going to say that it means to examine or to study, kind of look at something into great detail. If I'm going to investigate, let's say, a rock, magnifying glass closely for all the divots and the color, and I'm going to spend a lot of time looking at that rock. Okay. Also, another definition would be to search out and examine the particulars of an attempt, in an attempt to learn facts about something. And so again, we're going to use those two definitions to come up with a scientific investigation.
I will.
Okay.
We have, what does method mean? Again, a method is going to be a procedure or a technique, a way of doing something. It's a manner or a mode of procedure. And so, let's see. Okay, I'm gonna do, okay, here we go. So if I give you an example, if I say, okay, think of making a phone call, how can that be an example of a method or a mode of procedure?
I don't know.
It's kind of off the wall. It's kind of not really related to science, but it's going to help us remember the definition for method. So again, thinking of a phone call, if I want to call the right person, I'm not going to be able to call the right person unless I use the specific procedure in dialing their number.
Oh,
If
yeah,
I
sure.
just go ahead and dial any number in any order, I am not going to get the person that I want to. Okay, So kind of there's a specific method or a procedure in even dialing the phone was my point. Okay, and then another word that's going to pop up. How would you explain experiment? Oops, sorry. Oh my God.
Something you experience, like you put chemicals together or something you try to find out, something that you're trying to find a solution to.
Okay, very good. Excellent. I like that. To try and find a solution to something. That's perfect. So if we go dictionary route, it's going to be a test or a trial or the act of an operation for purpose of discovering something or testing a principle or, again, finding a solution. I really like that. Thank you.
You're welcome.
Okay. So in order, I threw these words together. So in order to scientifically experiment, we need to investigate using a certain method. And that method is, dun, 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 the scientific method.
Ugh.
Oh, come on. It can be fun, I promise.
Oh, yeah, sure.
So one disclaimer I wanted to say is that if you Google scientific method on the internet, you're going to find different versions. So some resources will use different wording, some will use different steps, some will use fewer steps, and some will be a lot more complicated. So I just came up with a couple different versions of the scientific method, but it's all the same. It's the method, the steps are the same, no matter how it's written down on paper or visualized, okay? So don't get overwhelmed. All right, so the first step is going to be asking a question about something that you've observed, okay? So if you walk out and say, well, why is the sky blue? Right? You could set up a question and a scientific method based on that you saw the sky being blue. You are going to ask the question to solve the question. So it's kind of the who, what, where, when, why, which, or how of science, of your observation. Okay? The question usually shows a relationship between two variables. So if I do, let's say, if I fail to feed my dog, what's going to happen?
The dog's gonna get hungry.
Yeah, exactly. So there's a relationship between me feeding the dog and the dog getting hungry. Okay, so those are two variables. If I forget to, or let's say, how does light affect flowers?
The flowers won't grow.
Exactly. The relationship would be that the flowers aren't going to grow, for sure. Okay, so some other examples of some scientific method, maybe some science questions. Where do ocean currents come from? Would be an example of a question that we could go through the scientific method. How do you keep an egg from breaking? Why does ivory soap float? And we can go on and on and on. We've talked about flowers. We've talked about feeding dogs. What other examples could you think of?
Not doing the dishes?
Oh, yes, exactly. So what is that going to affect if you don't do the dishes?
Not clean dishes.
Yeah, exactly. You're going to be eating using your hands and yeah, off the paper plates for sure. Yep. What else could we think of?
Can cause bacteria.
Yes, for sure. It could potentially, we could start noticing a strong smell from the bacteria that's growing on our dirty dishes. Perfect. Thank you. Okay, so for this session, I thought we could use the question, how does the amount of water affect the growth of plants, as our question. That's going to be our question. That's going to be our experiment. So how would you answer this question if you could?
Well.
Sorry.
Good. If you put too much water in a plant, it could die, get over drowned.
Okay, so we could have too much affecting the growth of plants. What else?
Not enough water for the plant to grow. If you don't put enough in there, it could die because it doesn't have enough water to drink off of and grow off of.
Perfect. So the amount of water has to be just right. If we give it too much, it's going to drown essentially. And if there's not enough, it's going to shrivel up because of thirst.
Mm-hmm.
Great. This question is a little bit easier because we can read it as adults and say, okay, yeah, we know that plants need water to grow. But there's when learning the scientific method, it's easier to go through an easier question. So the next step after we've asked our question, again, how does water affect the growth of plants? We are going to make a hypothesis. And before we do any of the steps of our procedures, before we manipulate any variables, we are going to make a prediction. And like I said, not always will the answer be straightforward, like what we said about our question. Okay, so a hypothesis, we are going to make an educated guess. So I could say, if I know nothing about watering plants, I could say, well, I think if I put a whole gallon of water every day, the plant will turn purple. Okay, so that could be my educated guess. If I know nothing about water, if I know nothing about plants, that could be my educated guess. So we kind of already talked about what we would hypothesize when dealing with the water and our question. A lot of times, if you are not familiar with the subject, another step in between asking questions and hypothesizing is going to be doing research. Is there a way that a plant can turn blue just from watering it? No, not really. There needs to be something a little bit more, maybe some blue water, for example. So having that background information to make an educated guess is pretty important. Any questions so far? I feel like I'm talking pretty fast.
No.
I'm into biology too.
Okay. Am I going too fast, or is it good?
Not for me. I've already been through that.
Okay. All right. Awesome. Well, thank you for the input. All right. So again, when we're writing a hypothesis, we have variables that are going to become important. So we have independent variables, or the lesson in the biology class called a manipulated variables. And those are what are going to be changed for the experiment. We also have our dependent or resulting variable. And that's going to be what is happening because of what has been changed. And our dependent or the resulting variable is what we're going to watch and collect data over. We also have a control variable. The control is going to stay the same throughout the entire experiment. Nothing is going to change with that control variable. So I could say, if I do this, then this will happen. So if I, again, fail to feed my dog, then most likely the dog will get sick and possibly die, okay? So what could be our hypothesis for our question? And again, our question is, how will the amount of water affect plant growth? What could we say?
What was the question?
So what kind of hypothesis could we write for our question? What or how does the effect of water affect plant growth? How could we write that as a educated guess or make a prediction?
You need the right amount of water for plant growth.
Okay, so if let's use that format on our screen. So if we do what?
use the right amount of water.
Okay, if we use the right amount of water, then what will happen?
The plant will grow.
Perfect. Okay, so if we use the right amount of water, then the plant will grow. Yes, for sure. Okay, excellent. Thank you. All right, the next step is going to be gathering our materials. So we need to come up with a list of materials for our experiment. Okay, and so I'm just going to go ahead and type, what materials do you think we're going to need to perform our experiment?
Well, you need water and you need the plant for sure.
Okay, we need water, we need plants.
You need a plant.
Okay, we need plants, we need water. What else?
A measuring cup.
Ooh, good one.
The soil.
And light.
Ooh, soil, yes, good. Soil and light. Good. Are we missing anything?
A shovel.
Nope.
A shovel? Okay.
Maybe if we're planting in the ground.
Okay, awesome. Yep. Okay, do that. Well, okay, now let's think of this. If we're planting them in the ground, can we control all variables?
No,
What couldn't we control?
because it could rain and it could be too much, or it could not be rain and it could be not enough water. So it could be either way. It could ruin either way.
Okay, so where would our experiment give us the most accurate results? Where should we conduct this?
I think that we should leave the plant in the plant box thing and put it somewhere where there's light, so that way if it's outside, like we should put it inside where there's light. That way there's not too much water, not too much light. That way we don't mess up our experiment.
Okay, that's perfect. So I'm gonna get rid of shovel since we're gonna do this inside. So what am I gonna need to put the plants in?
Like a bucket or something?
Yeah, like a pot, right?
Yeah.
Okay, so when we are gathering our materials, I know, yes, of course, it's hard to think of a flower pot because, well, duh, of course we're gonna need one. But when we're gathering the materials, we need to be organized and make sure that we have all of our materials in hand. All right, so water, plants, measuring cups, soil, and light, and a flower pot. What else? Anything?
Not that I can think of.
Okay, I think that looks pretty good if everybody's in agreement.
Yep.
Okay. All right, so next we're going to go to the experimental procedure. This is where our hypothesis will actually be tested. So we'll be able to see if we are right or wrong on our educated guess. So when we are dealing with an experiment procedure, we are going to create a step-by-step detailed plan on how the experiment should work. Some people like to think of a procedure as the recipe for your experiment. So if I were to write my procedure with enough detail, I could give it to Sarah, and Sarah could conduct this experiment, and then Sarah could pass it on to Rebecca. Okay, so it helps everybody in order to complete the experiment. So maybe the first step would be to use the soil and plant our plants in the flower pots. Okay, we need to do that first. There's a couple of questions. So during the procedure, it's only important to make sure you change one variable at a time. Why? Why would this be important?
Because if you change one thing at a time, it could change the whole procedure. So you have to do one step at a time because too many things can throw off the procedure and it can turn into a totally different result.
Okay, good. Very good. Anyone else have some feedback?
Well, if you put water in the pot before putting the soil and the plant in, it could be not enough water.
Okay, very good. Very good. And it's important to always have the control because that's what we're comparing everything to. And in regards to only changing one variable at a time, we need to only change one. That way we know exactly what's being affected. Because if we were to, let's say, change the soil that we're using and change the amount of light the plant gets along with the water, we're not going to know really which one is affecting the growth of the plant. Does that make sense?
Yeah, it does.
Okay. And then most of the science world will recommend that a procedure be carried out multiple times. Why? Why would this be important? Or recommended, I should say.
I have no idea. That's a confusing question.
Well, we
I
could.
have no idea either.
I'm sorry?
I have no idea either.
Okay. You always want to carry out an experiment multiple times because you want to make sure that your results are accurate. For example, if you carry out an experiment, let's say, okay, so back to my poor dog that I'm neglecting to feed, which I don't neglect to feed my dog. I just want to throw that out there. If I fail to feed my dog and the dog dies, well, okay, does that mean every time I don't feed the dog, it's going to die?
No.
No, it doesn't. So it's not a very accurate result. So if I am doing plants, how would I carry that out multiple times? Would I need to do one plant at a time? Or could I do multiple plants?
Depends on what plants you have and what you're doing to the plant because certain plants may be different and you do one thing to one plant and then try to do it to another and they're two different plants, it might turn out different. So, I mean, you might want to check to see how much water or how much, seeds or whatever you're trying to do. That way it comes out the same or it might come out different depending on what you're doing and what kind of plant it is.
Okay, good. So could this be an example of our experiment?
Yeah.
Why?
Because they're all different and yeah, they're all grown, but I mean, it looks like our experiment, but they're all different kind of plants. So we been doing different things to each plant for them to grow like that.
Well, why can't I just have 3 different plants?
You can, but I don't know. That's confusing. I just lost myself.
You're doing a great job, Sarah. If I use 3 different plants, I'm changing more than one variable.
Oh, yeah, you are.
Okay, so our experiment would look something like this.
Oh, yeah, it would, because they're all the same, and you'd be doing the exact same thing to all of them, so they turn out the same.
Exactly. Okay, the only thing that I'm going to change is how much water I give them a day.
Oh, yeah, true.
The only thing I'm going to change. They all have the same amount of soil. They all are the same flower. They're all going to receive the same amount of light. It's just a matter of water. Okay? Does that make sense?
Yeah, it does.
Okay. Any questions so far?
Nope.
Okay. All right, so as we are conducting our experiment, For this one, as we're watching plants grow, we are going to be collecting data as we experiment. So when we collect data, we are going to collect both qualitative and quantitative observations. What is qualitative?
I have no clue.
Me neither.
Okay, so if we look at qualitative, if you look at the very beginning of that word, it kind of reminds you of what?
Quality.
Quality, exactly. So what do we use for quality? We are going to use words, okay?
How
So,
much of something?
I'm sorry?
Quality, like how much of something?
Yeah, exactly.
Or something?
Yep. So if we're going to say, okay, on day 3, my C plant, if I go back to my experiment, my C plants, the petals were turning brown. Okay. That would be something significant that I would want to write down. Okay. Using my words. Now, quantitative is going to be quantity. So that's going to refer to the numbers. Okay. So I'm going to use both words and numbers. So an example of number observation, I could say, all right, my flower A has grown 5 inches over flowers B and C.
Oh, okay.
Does that make sense, the difference between those two? Any questions on those two?
No.
Okay. All right, so when we collect our information, our results, typically we are going to collect them in data or charts and graphs. So if I look at this, I might kind of make it a little bit bigger. Okay, we can see we've got a graph comparing speed to time. So we talked about independent variable. Independent variable is something that is not, or that is going to be changed. It can stand alone. It's going to be changed. In this example, which term, speed or time, would be the independent variable?
Would it be speed?
Why?
I don't know.
I appreciate your thoughts. I love your attempts, so thank you. Actually, this one's a little tricky. Whenever you have time, time is always changing, right? We can't stop time. Can we stop speed?
Yeah.
Yes. So for this example, our independent variable is going to be speed. Or sorry, time. Because time is going to pass no matter what. But our dependent variable is going to be speed because it's going to depend on the time. It's going to be the result of the time passing. Does that make sense?
Yeah, it does.
Okay. So okay, we're going to collect some data here. Okay, so this is my chart.
Yeah.
My independent variable is always on, I'm going to take this and I'm going to move it down. It's always going to be on my x-axis, okay? And then my dependent will always be on the y, okay? So in our example of how does water affect the growth of plants, what would be our independent variable?
The time. No. The
In
speed.
our example of our flowers.
Oh crap. Forgot about that. Wouldn't it be the speed?
No. So if we're looking at our 3 potted flowers, and remember we're only changing the amount of water.
Oh, okay. So it'd be the time. No. I don't know. It was confusing.
No, you're doing a great job, Sarah. I appreciate it. And it's good to be confused because we're going to straighten that out. So if we are changing the amount of water, that's going to be are independent because we're changing that. We're manipulating the amount of water. Okay, does that make sense?
Yeah, it does.
Okay, so my independent is going to be my amount of water because I can change that and I can manipulate that. So my dependent variable is going to be the result of my independent variable. The result would be what?
The wouldn't it be the heat? No.
The what?
I don't know.
You're thinking, you're trying your best. That's all I can ask. So what are we going to, let's say, what are we going to watch over this experiment? What are we going to look for?
How basic or the plant,
Something about the plant. What about the plant are we going to watch for?
how it grows.
Very good. Excellent. So the dependent is going to be the result of the amount of water, and that's going to be our growth. Okay? So the amount of water is going to depend or is going to result in the growth. Does that make sense?
Yeah, it does.
Okay. Are you still confused?
No. Okay.
Not as much? Okay. And then we have our conclusion. And this is a step where we tie all of our work together, okay? We usually write a detailed writing about our results, and we kind of go through a series of questions. So does the data that we collected support our educated guess?
Yeah, it does.
Not, why? Okay. What was our procedure? Okay, we kind of went over that a little bit quickly, but if we were to have written all of this down, kind of we would summarize our procedure, and then maybe there was something that we noticed we should have done differently. So that would be, our conclusion would be the place where we would write, maybe we should try this next time, or definitely don't do this again, okay?
Yeah.
And then this is where we would explain the relationship between the independent and dependent variables. Okay.
Okay, that works.
All right. Any questions over the scientific method or scientific investigation?
Hold on. Oh, there we go. I got you back. Never mind.
Oh, okay. Again,
Froze.
it's a very cyclical process, because again, if we go back to our conclusion and we notice that there were some problems in our data supporting our hypothesis, then we could go back and start the experiment over. Or we maybe thought of a few more things that should be added in our procedure, then we could start the process over and change. Okay, so it's very cyclical. It's an ongoing process for sure. So,
Yeah.
any questions about that?
Nope, I'm good. I'm not confused no more.
Promise?
Yes, on this part, yes, I'm not confused at all.
Okay. On this
Good.
part. Awesome. Okay, so again, we have a biology activity that this live session was based on. However, it's going to be just kind of review questions about what we just learned. So in the following lab problem, what is the manipulated variable? So how does light affect plant growth? What is
how it grows?
so the manipulated variable? What am I going to change?
The well, you could change the water, but I mean, how much or how not too much you put in there for it to grow, but
So we talked about how much water is going to be needed. This is asking, how does light affect plant growth? So what am I going
if it's too I think. Well, if you don't have enough light, then it can make it die.
So my manipulated variable is going to be
The light?
The light, exactly. Very good. So, for example, I could put one plant in 24 hours of light. I could put one plant in 0 light. Okay, so that's what I'm manipulating. I am physically changing their environments. Okay, good.
Gotcha.
All right, so the controlled variable in an investigation is what? Is what is measured, is not needed, stays the same to provide a comparison, or can be changed.
Hi, Melissa.
Hello. What do we think the controlled variable would be?
Probably what could be changed.
Well, if it's a control.
Oh, it stays the same, but it provides a comparison.
Very good. Yes, it stays the same. Think of speed control.
Oh,
okay. When you put your car in speed control, what typically happens?
It changes?
No, the speed should stay the same, right?
Oh, yeah.
Okay. So controlled is what stays the same so I can compare things. All right. So the manipulated variable is what you are measuring in an investigation. True or false?
True. No.
I'm sorry, I didn't hear you.
True.
Well, okay, so not quite. It's going to be false because remember, if I go back to the experiment, how does light affect plant growth? You told me that the manipulated variable was light.
Oh, okay. I see what you're talking about. Yeah, it would be false. Never mind.
Okay, so it would be false because in this particular lab, what would be the variable that I am measuring?
The water.
Nope. How does light affect plant growth?
Oh, you're measuring the plant.
Yeah, exactly. Very good. All right, so the responding variable or the dependent variable is what you are blank based on the changes of the manipulated or independent variable.
You're comparing the, wait.
Predicting, measuring, proving, or comparing.
You're comparing the two because you're, no, you're measuring the two because you're trying to see which one, like how far it grows and what it does or whatever. So you're measuring both variables and see what the change variable would be afterwards. So you're measuring the different results.
Very good. Perfect. Very good. I liked how you caught yourself from comparing because comparing is going to be our controlled variable. So nice job. All right. And then the last question on the assignment was to kind of go through the 6 steps and kind of number them in order, like what we just talked about. So what would be number 1? What would be the very first thing I would do?
You would actually, we would get the plant together and we put all the stuff in the thing to make the plant grow and how much water and stuff it is to get the result of the plant.
Before that, even before that.
You'd have to get all the materials together.
Before that.
Before that? Crap. Bring my head hurt.
So it's all right. So and I think we overthink this step. We kind of, oh, well, I've already done that in my head. Why should I make a note of it? But if I am making observations, there's some question or problem that I have.
Oh, so we have to figure out what the question is and what the problem is to figure out how to fix it.
Yes, very good. So my very first step is going to be state the problem or questions.
Find the solution. Okay? Yeah, try to figure out what the problem is and how to fix it.
Very good, yes. So then my second step to carry out an investigation after I have asked a question or stated the problem is going to be which step?
To figure out how to fix the problem and how to figure out what you need to do to fix it.
Okay. Yes, but there you're kind of missing an important factor.
Gotta be a but.
So after we ask a question or state a problem, we're going to make a hypothesis. We're going to give an educated guess as to what we think the answer will be.
Yeah, you have to do the, you have to guess what the answer might be and what the problem might be.
Yes, very good. Okay, so after we have asked a question, we're going to make a hypothesis. Okay, now what?
You gotta gather all the materials. That way you have everything that you gotta have to try to figure out the problem and trying to make the right solution.
Excellent, very good. So I've asked a question, I have made a hypothesis, I've gathered my materials, now what?
You gotta put all the material, you gotta get all the materials and put them together to make your product so you can get to the finished product.
Okay, so would that be carry out the procedure, conclusion, or collect data?
Collect data. No. That would be the gathered materials because you're trying to get everything together.
Okay, so after I've gathered the materials, what am I going to do to let me collect data?
You got to state the problem and the question to figure out what data you have to collect to fix the problem.
Okay, so yes, so in order to do that, I'm going to carry out a procedure. Oh, it won't let me. Shoot. Let me just edit this a little bit. Okay, so in order to solve my problem, I have to create that procedure. I have to carry that procedure out, that step-by-step recipe for the experiment. Okay? Yeah. And then during the procedure, I'm going to be collecting my data in order to see if my hypothesis was correct or accurate. And then, last but not least, I am going to bring it all together and kind of summarize what I learned, what I saw, what I gathered. Okay?
To make your hypothesis and see if it came out to the solution that we thought it was going to come out to?
Yep. And again, the conclusion is someplace that I would write maybe suggestions for future experiments to kind of see changes or improvements that I could make. Okay?
Okay, that works.
Good. Okay, questions over that?
Nope.
Okay. All right, so during our live sessions, we like to cover kind of like an important study skill. And so I wanted to focus on some time management today. Okay. And I'm sure that you've heard these before, but they're good reminders just to stay on top of
that works.
Okay, so in my mind, the most important thing to do in terms of managing my time is to stay organized. Okay? There's nothing worse than sitting down to do some work and I can't find my pencil, or I can't find my notebook that I've got all my information in. My 3-year-old ran off with it and I have no idea what happened. Right? That's very frustrating. That's not using my time efficiently. Okay.
Yeah.
And when we were in high school, you had homework and you forgot your textbook at school.
Yeah, I remember those days.
Yeah, me too. We all were there.
Or dog ate your homework, one of the two.
Yes, exactly. At least he was eating something since I forgot to feed him. Also, it kind of helps just to have your own space. Yeah. Whether it's at the kitchen table. Mine in high school was always my bedroom. You know, I just went in there, turned on my music, and studied.
That was me too.
Yeah, that was my place. Okay, so it is important to have your place, kind of your organization in your spot. Do you use a calendar?
I do.
Okay. So I love my calendar. I love my planner, and I do make weekly to-do lists. And when the family or school gets really busy for me, I will do a daily checklist.
Yeah.
And I am a person who finds it very satisfying to cross things out on a list.
Yeah, which I need to start doing because I haven't been using the calendar lately, and I've got to start putting in the dates for when some of the assignments are due because I forget, and then I try to go back and do them, and they're already due.
Yeah.
So I've got to start doing a calendar.
Is there a calendar on your dashboard?
I don't know if there is or not.
It says calendar right here, honey.
No, not that. That's hers. I don't know for sure. I can check.
Oh no, that's okay. I can look at it too because that would be very helpful if there was.